Imagine being behind the wheel of a high-powered sports car, believing you're making every turn an acceleration decision. Yet, unbeknownst to you, there's an invisible co-pilot, subtly steering you away from obstacles and sometimes even taking full control. This is akin to the relationship between your conscious mind and the vast, enigmatic landscape of the unconscious processes in your brain. Today, we're diving deep into this relationship, inspired by the Nova episode, Your Brain, Who's in Control? Let's start with a staggering fact. The human brain, with its 90 billion neurons, is a masterful deceiver. The complexity of our brain goes far beyond the surface of our conscious thoughts. While you might be aware of this text, many other processes, from your blinking to your emotional reactions, operate under the radar of your consciousness, governed by an intricate network of unconscious activities. Delving into the dynamics of conscious versus unconscious control, we encounter a surprising scenario. Sometimes, regions like the prefrontal cortex, known for its role in rational decision-making, get sidestepped by other brain areas during phenomena such as sleepwalking. This phenomenon perfectly captures the brain's complexity. According to a manual during studies on sleepwalking, despite parts of the brain powering down into deep sleep, the motor cortex remains active, guiding the body in a semi-awake state. This reveals that our brains can operate on autopilot, executing sequences of complex behaviors while our conscious self is none the wiser. Emery Brown's research with Anesthesia brings another layer to our understanding of consciousness control. Anesthesia doesn't just put you to sleep, it strategically dims the communication across various brain regions, transforming active, chaotic brainwaves into synchronized, sluggish waves. This is akin to reducing a bustling city to a ghost town, inhibiting the lively interactions that typify consciousness. But what happens when the communication lines within the brain get cut more permanently? Split-brain patients, whose corpus callosum connecting the two hemispheres has been severed, offer a startling view into this scenario. Each hemisphere can develop its own perceptions, thoughts, and priorities, challenging our conventional views on unified consciousness. It's almost as if two separate consciousnesses reside in the same skull, occasionally cooperating, but often operating independently. The brain's complexity is underlined further through emotional and social influences on decision-making. Luke Chang's studies in behavioral economics, particularly in the trust game, illuminate how our brains are susceptible to emotional currents. Feelings like guilt not only affect our social interactions, but activate specific brain regions, such as the insula, indicating that our decisions are less about rational choices and more about emotional responses. Transitioning to genetics and environmental impacts, the work of Bianca Jones Marlin provides a gripping narrative on how trauma can reshape gene expression across generations. Through her studies with mice, she shows that traumatic experiences can enhance the sensitivity of neural receptors in progeny, suggesting an inherited component to trauma response. This interplay between genetics and environment underlines the unseen yet profound influences molding our brains and behaviors. Now let's focus on an often overlooked character in this story, the thalamus. This tiny structure, nestled at the center of the brain, acts as the grand central station for sensory and motor signals. Understanding its role, especially in the context of anesthesia, where brain communication is dampened, highlights how delicate our grasp on consciousness is, dependent on the integrity and functionality of this small yet pivotal brain part. The illusion that we are singular, unified identities under complete self-control is one of the brain's greatest tricks. As we navigate through life, much of what we do and how we react is sculpted by unseen forces within the recesses of our mind. The interhemispheric communication, crucial for a coherent sense of self, when disrupted, provides a window into how compartmentalized our consciousness can be. Ending on a note that might tickle your curiosity and perhaps a bit of existential pondering, consider this. If so much of what we are is governed by unconscious processes, are we ever truly in control? Or are we merely conscious spectators in the complex theater of the brain's workings? This journey into the brain's hidden mechanisms invites us to rethink our understanding of consciousness, identity, and self-control. It's a profound reminder of the intricate and mysterious nature of the human brain, forever challenging our perceptions, shaping our experiences, and defining our existence in ways we are only just beginning to understand.